Surron 80 volt battery pack, number 2. Why am I building another? Well, this is for my new street bike build, which will be coming out this spring. As you may know, I published a full DIY battery pack build video about a year ago. I won't repeat all the information from that one here. I will just be going over what's changed, what's been improved, what I've learned from the previous battery pack build, and even go over some new mistakes that I made in this video. Yes, I've made new mistakes. But in general, that first pack with the Samsung 40Ts is performing great. It's been flawless for about 4,000 kilometers. So briefly, what's different about this pack? What are the improvements? First of all, I'm using the great Molicel P45B cells, capable of 50 amps peak. That means that this pack will put out a genuine, with voltage drop, 405 plus amps and 32 plus kilowatts. My battery test that I performed last year showed that the P45B performs much better than the Samsung 40T, with much less voltage drop and temperature increase. Next, this pack will be getting a new amp BMS that's capable of 220 amps continuous and 550 amps peak. The old pack had a 130-300 amp BMS. Also, it's getting a new metal case, not the 3D printed case like I used on the last pack, although that 3D printed case has been okay and held up good. It has a more compact design than the previous one and is about 10 millimeters shorter. And finally, I'm using the same great copper nickel bus bars that I used in the previous build. These can easily handle 400 plus amp peaks. So here we go. Sit back and enjoy watching the new pack build. Okay, I'm going to speed up this section here and just give you the really brief version because this complete segment is going to be in the upcoming street build video, so no need to repeat it here. The short version is I calculated the actual maximum power output of this pack, and in order to do that, you need to calculate the power output, including voltage drop. You can't just say that the pack is 92.4 volts fully charged, and then you multiply that times the amps and get the power output. So the good thing is, in the past year, I've done many battery tests. You can see all my battery test videos on the channel here, and I've been able to measure the real world voltage drop under different conditions. So for this pack, we're using P45Bs. The maximum spec output that I have for that is 45 amps, although they can do quite a bit more, 50 or 60 amps, and the voltage drop of the cells immediate after 5 seconds at 45 amps is about 3.53 volts. So we have to look at it in that light, that the actual pack voltage at that power output is going to be 77.66 volts, not the full 92.4 volts. So if you take that voltage and multiply it by 405 amps, you get 31,452 watts. It's not 32 kilowatts, but keep in mind that you can just bump up the amp output on the cells a little bit above 45, and it'll be easily able to hit a real world power output of 32 kilowatts. Keep in mind, of course, that your maximum power is limited by the lowest of your 3 main components: the motor, the controller, and the battery pack. Okay, here I'm starting to test all the cells for voltage and IR. In the past, I just tested everything for voltage, but I decided to test for IR too, because ACIR, as I showed in my video, is a good way to tell fake cells from real. So I suggest you get a tester like this one here and just check everything for ACIR and voltage before putting them in the pack. Everything was fine with these cells, except I did have 5 P42As mixed in with my P45Bs from Encon. Not sure how that happened. This is the third and fourth P42A that I've gotten together with the P45Bs. Fifth one. Probably won't even put this in the video. But if I do, guys, I can't believe I did this. I checked, double check, triple check. Make sure you triple check before you weld anything. Do you notice anything wrong here? I'm putting these things on, green, and I'm come to here and I'm like, wait a sec. It's supposed to be like 1 positive, 2 negative, 1 positive, 2 negative. How do I have 2 positive here? This cell, I put in backwards. I already welded the other side. I got to disconnect the weld and try and fix it. Unbelievable. Yeah, not a good start to the day. So, I wasn't even going to film this. You can say, what the fuck? Wasn't going to film this because it's embarrassing, but I need to show that even a veteran battery maker can F up. I don't know how I did this, how it was possible, but I put one cell in backwards. No, now it's fixed, but this cell right there, as I was on the other side putting the insulators on, I realized that this cell was in backwards. How I did it, I don't know how it's possible. I checked, double checked, and triple checked that everything was right. Anyway, one was backwards. So the 2 points from this: one is double check, triple check, and check again that you don't have backwards before you weld one. The other thing, this is a great example why spacers and these bus bars, it's absolutely the way to build a pack. My point, and I said a long time ago about why not doing glued together packs, because in the terrible event that one cell is bad, or if you do something idiotic like I did and reverse one cell, you can, I cut the other side and took the cell out that way. You know, I cut these little lugs, got the cell out, reversed it, and I decided rather than try to repair, tried to do a repair on one. Instead of trying to repair, I decided to just take this off and completely put another bus bar on these. So it's why spacers and bus bars are a great way, because besides being strong, if a cell goes bad in the future, if necessary, you can replace it. Yep. No, it's even pretty kind of crumpled, but yeah, I think most battery builders wouldn't even show this mistake because their pride would get in the way, but I think it's a learning lesson important to show. Double check and triple check and quadruple check. I was even doing, like, on all of them, I was going hopscotch, like 2 1 2 1 2 1 1 2 1 2 1 2. I was going across to make sure they were right. How did I F that up? I have no idea. But anyway, yeah, not fun job at all. Triple check so you don't have the same thing. But like I said, great point that this type of construction is awesome, because if God forbid in the future you do need to replace a cell, yeah, it sucks, it's not fun, but it is possible. The whole pack is not garbage, which is very great. There it is, cleaned up. And one other fun part of this is I don't have any extra of this direction bus bar, because these are needed for the other side of the battery, so I've got to use the bus bars for the other block. One fixed, one to go. So there we go. Yep, lost the better part of half a day to take these off and repair them. One other thing, good news, very, very hard to pry these off. Basically, the welds are stronger than the copper nickel, you know, so this welder, great job. Very strong welds, very secure. But yeah, took off, cleaned out both of these, cleaned out contacts, welded new bus bars on. So there it is, second side of the first block done without further drama. And yeah, redoing stuff is not fun, so definitely triple check your work. Okay, second block here, coming along without a major F up, which is good. Oh, that's bad. So yeah, looking better. No mess ups on this one. Just follow the hopscotch rule. 2 1 2 1 2 1 1 2 1 2 1 2, and just make sure. Double check, triple check. If in case you're wondering about these insulators, you know, positive insulators, if they're necessary or not. So I've spoken at length with my manufacturers of the bus bars, and pretty much the consensus is they're absolutely not needed if you use my copper nickel bus bars, these guys. You don't have to have these insulators. You know, it's fine without them. I'm just installing them as a little extra layer of protection, just in case, God forbid, there's a huge impact on, you know, the side, any side of the battery pack like that. Few new things this year. Gonna try this for the connection, thinner or just directly welding, we'll see. And got my separator plate here. Well, this is how it's going to be attached. I was really hoping to be able to weld just one of my pieces of 0.3mm copper here. I was going to try to weld it, just a piece on there to keep it nice and flat to save space. But my little welder, I tried it on maximum setting, didn't even make a mark. So with that welder, cannot weld this copper too thick pieces of it together. So unfortunately, got to do the soldering pad thing again. It's going to be thicker, and I'm really trying to conserve space because I'm using the metal case. Hold on. Because on this bike, we're using the metal case, not the 3D printed, and this is only like 390 millimeters high, which is basically the entire pack. So the BMS and the wires up there, they're all going to be inside a 3D printed cover. So trying to conserve space, but unfortunately the way I want to do it on the bottom, we're just welding another piece of copper across here. My welder absolutely cannot do it. Well, I'm not going to lie, that sucked ass. I mean, it sucked ass very, very badly. Worse than the first battery pack with the normal round thicker wires. I thought this would be kind of easier and better because of the flat wire. The problem is, it's just almost impossible. I know this looks like, you know, the gallery of cold solder joints. I've done it and redone it and redone it 50 times. I spent the better part of a day on this. The problem is heating the bus bar material enough so that you can make a solder pad so you get the solder to melt. I have here 4 soldering irons, my 2 that I used from before, this big Ukrainian 100 watter. On my tools there, even tried 3 different solders to see what had the lowest melting point. I got this cool new soldering iron from Ali, 100 watt. It's a very cool thing, it works well. The problem is all of them don't have enough power. They barely have enough power to heat this. You put flux on it first, really heat up the pad, the bus bar, and then try to melt some solder on it to make a pad. And then obviously the point is you do pads there, then the wire goes on, you just melt some solder on, and those stick to the existing solder pads. But I'm sitting here thinking about other solutions for this connection part, because like I said, doing this really sucks ass, very bad. There's a few options, a few variants. Some people, well, let me first say about bolting, because these do have holes to be bolted, and if you were to, you know, run a screw short one through here and bolt and connect the wire, you could do it where the holes are, you know, not where the cells are obviously, but where there's air there. It's a possibility. Obviously it would be quick and easiest way to do it, but the problem is in the Surron world we don't have extra vertical space. Yeah, if this was a 72 volt pack, 20S rather than 22, then we have some free space up top in your case. But because this is a 22S, wanted to do 80 volt again, our vertical space is already too big. So bolting is obviously a quick and easy way to do it, especially if you have a 20S pack. But with 22S, we just don't have the vertical space. Like I said, I did try welding the two of the copper pieces together. I did it on the test pieces, and my welder, you know, the Minder RC one that you've seen before, that just absolutely doesn't do it. I'm sure there are big enough welders that can weld together 2 0.3 millimeter, you know, copper sheets. So if you have that kind of welder, that would be a great option. Something else that I think one person mentioned in the comments in the original battery video, and I think it's actually probably the best idea, but it's a little tricky, is if instead of these 2 end bus bar pieces, you know, like these 2 short ones we have here, if instead of these being 2 pieces, these 2 end pieces were 1 piece that has a connection here and then extends straight out and has a connection here. So what I'm saying is these bus bar would be 1 piece. So if you imagine this flipped as one long block, you would actually just continue welding straight across your 22 series, and then you would have to carefully flip it over, fold it down, and then you would have just a clean, you know, no extra space there, and a clean, nice connection. But there's a few problems with that. First is you have to get your welding on your series, where it connects there especially, totally straight. You would need to like line up, you know, both blocks with a straight line. No, straight edge. Make sure it's totally straight. And the other thing is too, I mean, you're gonna make a pretty tight bend. Like the only thing in between these 2 is really like 1.5 millimeters of this FRP sheet and plus the green stuff. So you're gonna be making a pretty tight, not even a 90, but 180. Sorry about that focus. You're gonna be making a really tight 180 degree bend in the copper. And I've tested on the bus bars, I don't have one here, but I've tested just to see how many flexes, how many cycles of flexing 90 degrees back and forth they take before they break, and it's a lot. You have to do that back and forth probably 25-30 times before it breaks. So I'm sure doing 180 degree bend like that would require would be not a problem for structural integrity, but I don't know. I don't want to ramble here. Just like I said, trying to think of some other options. I think where, like I said, the bus bar where it just continues and welds together, so you have one long line. So this is one piece, and then you flip it over. That's a good option, but it is a little bit risky. Bolting, like I said, you don't really have space unless you're doing a 20S pack. And welding, if somebody has successfully welded two 0.3 or two 0.5 copper sheets together, well, for doing these things, this soldering iron does great, no problem at all, melts it in just a couple seconds. Keep in mind that, of course, this copper is the same thickness as it is over here on the bus bar. The problem is just, having a huge area of it. It's hard to heat up one section at a time, but this is actually a 100 watt maximum iron. I do need to crank it up to about 400 to get it to melt this solder. Got a couple different kinds of AliExpress solder. This blue, seems to be working a little bit better than the one in the white. I ran out of my Topex from Ukraine here. But anyway, this works great on the smaller things. It does, barely melt it on there for my big wires and for this. But, I tried every soldering iron I have, including the 100 watt, and doing this kind of stuff, really almost impossible. Yeah, I don't know why, but this is worse than previous packs I've done. Just can't get the copper to heat enough to make the solder pads, even with this on maximum. Tried my other soldering irons too. I don't know if it's the solder. I tried both of these AliExpress ones, but out of my Topex anyway. Very difficult. Definitely, like I said, take my own advice that I didn't do this time and do these pads with these off before you weld the battery pack, so you're not heating the cells, because obviously the longer I'm trying to heat these, the more it heats up the cells, which is not good. So here's how that mechanical connection looks. Problem is, even if I kind of tuck this down in there, BMS is not really going to fit. It has to go kind of halfway over this bus bar, and this just makes it too tall. No way really to get it to work. What I realized is that just the tip, as is often the case, was not enough. Just the tip was not heating it enough. It was just not melting on here. What I had to do was, I first kind of did flux, sort of preheated it with the tip, and then I used the side of the soldering tip here, the side with full contact on the solder and on the pad, and just kind of swirled it around, and that, by doing the side, was the only way to get it heated up enough to actually melt the solder on there. So had to make a quick trip in a snowstorm to Epicenter. If you guys don't know what Epicenter is, then come to Ukraine and you'll see what it is. Got this beast, 200 watt. Yeah, I haven't used one of this type before. Hopefully that does the trick. Also, right around the same time I switched to this soldering iron, I ran out of the previous solder I had, which was Topex, made in Poland. Worked quite good. So I got another package of Topex, and the thing is, this costs about 12-13 bucks for 100 grams. These from Ali were like 60 cents and $1. So a little bit of a difference in cost. I don't know if the problems I'm having now, because it's much worse, it's like impossible, if it's more due to the solder or if it's due to just my irons can't heat it up enough. But I'm going to go back to the Topex. It works good, and these both had good reviews, by the way, but we'll see. Going to go back to the Topex and 200 watt. Hopefully that'll do it. And like I said, again, I'm repeating myself, but really much easier to do this and better to do it before you have it mounted on the battery, so you're not heating up the cells. Quick point I want to make is, these difficulties and all these problems of space and fitting in, this is solely because it's an 80 volt pack. If this was a 72, you would have plenty of space at the top here for BMS. For doing a mechanical connection, you'd have like an extra 20 225 millimeters of space here, and so plenty of space inside that 395 millimeter case. So because I'm doing 80, everything is much shoved in more, and you know, I don't want to have it be a tower and be that tall. So just keep in mind, if you're doing a 72, you will have a lot, only 20S instead of 22S. You will have a lot more space to work with in here, and you'll have more vertical space, so you could go ahead and do that mechanical connection if you prefer to. Holy crap. Yeah, there's something to be said for having the right tools. You know, I've been beating my head against the wall for 3 days trying to solder these big wires, and this 200 watt behemoth and Topex good quality solder, and 5 minutes done and connected good. This literally heats up and melts a joint in like 15 seconds, even less, and the Topex solder just flows like, you know, nectar of the gods, flows super smoothly. So these two things together, and this wasn't even that bad. So there it is, B+ done, and it only took a whole day and a trip to the hardware store, home center. Anyway, long story short, this guy is great for little stuff, you know, maybe up to like 12 gauge or so. Big stuff, don't even try it. If you're going to do this, definitely get 200 watt, get really good quality solder. I know if you're in US, you probably don't see Topex, but buy a really good quality brand. You know, these AliExpress ones had good reviews, but they're crap. This stuff just flows, like I said, like the nectar of the gods. And definitely do, you know, these before, like I said. I was monitoring the temperature, you know, on the cells as I was heating with this thing. I was monitoring how hot it was, and it got, you know, hot to the touch, but I would say no hotter than probably like 65, 70 degrees Celsius. I mean, it definitely wasn't too hot to touch, like where I burned my finger or something. So yeah, I mean, obviously not good to heat up the cells, heat up the bus bar here. So definitely better to do, like I said, do the pads, and you even B+ you can do before you weld the bus bars on. And on the other side of the connection, you can do all the pads and even one side of the wires. So anyway, hopefully my experience, that's why I do the videos, helps you to, you know, to do it better. Things going much better with the big soldering iron. It really helps a lot. Quick and almost easy, but not quite. But so if you're wondering, this guy can solder a QS8 just barely heats it up enough to do 6 AWG on QS8, but honestly, I'm going to do the big guns on this. And I just dropped this and broke the tip, which is cool. 4-into-1 turbo exhaust. Not bad. Got it squeezed in there pretty good. Redid this connection with the help of the big 200 watter, and yep, it makes all the difference in the world. Definitely, if you're doing this, get a 200 watt. Boot up, connection of the BMS wires, final checking of them, and booting up, always a stressful time. This is like the time that I worry something could go wrong, but looks like we got boot up okay. Okay, so this is how we fit in the box. About how I expected, a little bit smaller than the previous 22S pack. A little bit of space each way. Gonna have to custom make a 3D printed top, but in general it fits okay. Okay, the first Ampace JP40s have arrived. Took the long boat from China straight to Ukraine here. These are, sorry about that, these are LT labeled ones. I got all LT instead of the Ampace version. These are going to be for the upcoming new Surron battery pack build that's going to be capable of 630 amps plus and 48 kilowatts. Almost perfect. Almost totally perfect with my new 3D printed cap. Just a little bit tight over here where the wires come out. I need to extend that opening just a little bit. That can be shoved down, but anyway, very close to perfect. Super happy about that. Okay, haven't done a battery update video in a while. Been waiting for some other needed parts, small parts for it to come in. Made a new custom cap that fits perfectly, which is great. Here's my last, can't do it. Anyway, last thing I did before putting it in, did some protective foam because the battery has about 1.5 2 millimeters of space on each side with the case. Fits basically perfectly. So put a little foam, strips to make sure it doesn't move around. Now we just have to do the final mounting of the cap, and the only problem is screws. Short screws can fit okay. Problem is the height of the battery. These metal cases I got are only 390 tall. That's all I could find. So this cap is 25, which allows it to fit the BMS. It's actually a little bit shorter than my previous battery, which is great. But our bus bars, our B plus that are bent here, are right here at the top, level with the top. B minus there, B plus is there. And the problem is screws, I'm sorry if you can't see in there, screws cannot go in there because they would actually push into the B minus and B plus bus bars. They could actually push into it, or worst case scenario, you could have a short. If this touched the B plus and B minus, the case is metal, it's conductive, you could actually short the whole battery via the bus bars. So I got some nylon plastic M4 screws. I'll see if I can use those for the front and the back. I'm not sure, but I can get little M3 self-tappers on the sides, and it's held in anyway with the battery lid, the battery cover on the Surron. So should be okay, but making progress here and almost done. And that is pretty much it. I just have to clean up my hot glue here, silicone after it dries, cut the line nice and even. Did silicone all around the perimeter there, so hopefully we're water sealed. Got special M3, these are like glasses bolts, special little M3 by Short, 6 millimeter. Had to make sure they weren't touching the battery itself inside. Use nylon screws, M4, for the front and the rear. I know this doesn't look beautiful, but main thing I'm concerned with is that it's water resistant. So did silicone all the way around the edge. We'll cut it even, and I think it's going to be, pretty water resistant. I don't plan on riding in a downpour anyway. So that is pretty much it, thank goodness. Yeah, now I just have to make a custom thing for the charging port. I don't want to really leave it like this. There was just absolutely no space anywhere in here or there for the female charge port, just totally full. Well, she's charging through the port there. That's pretty much it. I need to try to clean up my silicone a little bit there. This also have a little difficulty with the thick battery wire fitting in there. Might have to raise those up a little bit. Charge port thingy works. I mean, obviously we'd be better to have it on the battery, but just there was no space at all in there. Hopefully, I don't think it's going to hit my leg when I'm riding. So yeah, she's mostly done. Happy to say. Hopefully going to be fun to ride. How about that? Ooh. Well, strange noises we will figure out later. But hey, it works!